Good morning to all. Ohm's law. It is a topic now we are going to discuss. In this video lecture, we are going to know about statement of Ohm's law, limitations of Ohm's law, VI relationship for resistor, inductor, and capacitor. Finally, series and parallel combination of circuit elements. These are the topics now we are going to discuss. It is useful for all the first year students who are studying the subject basic electrical engineering. Let us take the first one, statement of Ohm's law. Ohm's law states that the current through a conductor between 2 points is directly proportional to the potential difference across the 2 points. In mathematical form, you can write current is proportional to voltage, that is V is equal to IR. Here resistor R, introducing the constant of proportionality, the resistance 1 arrives at the usual mathematical equation that describes this relationship. From the equation V is equal to IR, you can write I is equal to V by R, where I is the current through the conductor in the unit of amperes. V is the potential difference measured across the conductor in units of volts. R is the resistance of the conductor in units of ohms. The diagram shows the meaning of the statement. All you know well that ampere indicate the flow of current. It is directly proportional to voltage because voltage is nothing but force. Based on the force received by the conductor, the current flow takes place, that is current is directly proportional to voltage. Here is the ohm, that is resistor. If you are increasing the ohms value, then current value, that is amps value, will be minimizing. So this equation proves that current is directly proportional to voltage and inversely proportional to resistor. If resistor value increases, current value decreases. Then the limitations of Ohm's law. It is not applicable to the nonlinear devices such as diodes, Zener diodes, voltage regulators, etc. It does not hold good for non-metallic conductors such as silicon carbide, that means semiconductor. Let us take the VA relationship of each and every circuit elements. They are resistor, inductor, and capacitor. Dear students, all you know well about circuit elements, resistor, inductor, and capacitor. Resistor is power dissipating element, where the inductor and the capacitors are energy storage element. Resistor, it resists the flow of current. Its unit is ohms. Inductor, it is energy storage element. It stores the energy in the form of electromagnetic field and its unit is farad. Here capacitance, it is also energy storage element. It stores energy in the form of electrostatic field and the unit of capacitance is farad. In this slide, VA relationship going to be explained. Resistance and its VA relationship means it is the symbol of resistor. Voltage is across the resistor. Current flow through the resistor is I, and the voltage equation is V is equal to Ri, whereas I is equal to V divided by R. For inductor, it is a symbol of inductor, and as we discussed earlier, inductor and capacitors are energy storage element. So voltage across inductor is directly proportional to di by dt. To remove the proportionality, we have to add a constant. We have to introduce constant, that is V is equal to L into di of t divided by dt. For capacitor, this is a symbol of capacitor, and voltage across capacitor is V of t. Current flow through the capacitor is I. In general, V is directly proportional to charge, that is Q. V is proportional to Q. Q means charge. In the equation, V is equal to 1 by C integral I dt. Here 1 by C is introduced as constant. From this we can get the value of current, that is I is equal to C into dV of t divided by dt. Now the series combination of elements. See, resistors R1, R2, R3 up to nth resistor all are connected in series. To find the equivalent value of the resistor or equivalent, all the resistors should be added, that is R1 plus R2 plus R3 up to nth resistor. All the resistors are added here. Then n inductors in series L1, L2, L3 up to Ln. To find the equivalent value, L equivalent is equal to L1 plus L2 plus L3 up to nth value. Then n capacitors in series. Here only we have to understand the difference between the series combination of resistor and inductor, where to find the equivalent value, all the resistors and inductors should be added. But in capacitors, the equivalent value obtained by having the equation 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by Cn. Finally, to get the C equivalent, we have to take the reciprocal of this equation. Then the parallel combination of elements. N resistors are connected in parallel. Here 1 by R equivalent is equal to 1 by R1 plus 1 by R2 up to 1 by Rn. Then n inductors are connected in parallel. Here 1 by L equivalent is equal to 1 by L1 plus 1 by L2 up to 1 by Ln. Now n capacitors are connected in parallel, but this equation is similar with the series combination of resistors. Here C equivalent is equal to addition of C1, C2 up to nth capacitor. Let us take an example. See the circuit diagram. Find the equivalent resistance between the 2 points A and B shown. First, students should identify where the series combination of resistors are provided. After that, they have to find the resistors connected in parallel. In the given circuit, the resistances 5 ohm and 6 ohm are in series connection, so they can be added. 5 plus 6 is equal to 11 ohm. And then resistances 3 ohm, 4 ohm, 4 ohm all are connected in parallel in the first row. So we can solve this easily. That is 1 by R is equal to 1 by 3 plus 1 by 4 plus 1 by 4. LCM of all 12. Then finally we can get 1 by R is equal to 10 by 12. To have the resistor, we have to take the reciprocal of the 1 by R, that is R is equal to 12 by 10, which is equal to 1.2. Now we have to redraw the given diagram after completing step 1 and step 2. In step 1, we have solved a series combination of resistor. In step 2, we have solved a parallel combination of resistors. So 2 ohm connected with 1.2 ohm. Again 11 ohm connected with 7 ohm in parallel manner. So 2 plus 1.2 both are connected in series. So 2 plus 1.2 is equal to 3.2 ohm. Now 11 ohm and 7 ohm are connected in parallel. So we can use the formula R1 R2 divided by R1 plus R2. Now apply 11 as R1, 7 as R2. So 11 cross 7 divided by 11 plus 7, which is equal to 4.277 ohm. Replacing the respective combinations, we have to redraw the circuit once again, where 1 ohm connected with terminal A and 3.2 ohm, 4.277 ohm. These two resistors are connected in parallel with terminal B. Again, we can solve 3.2 parallel with 4.27, which is equal to 1.8304. Now this 1.8304 should be added with 1 because 1 ohm connected in series with 1.83 ohm. So the equivalent resistor, that is RAB, is equal to 1 plus 1.8304, which is equal to 2.8304 ohm. This is the result. Thank you.